So we straight away try to actually establish a prefix tree first. So starting by the root, we go on to based on the rulebook of the item that it gave us. For the woods is therefore A, P, P, and of course we need to mark it as like an end of word. And we also have like APE, which is we already have like using the established. So what's actually happening over here is actually operation Z, where I add in all the alphabet, and then operation Y, I mark end of word. So operation Z add APP, operation Y mark end of word. This is to actually create like a brand new word, if you were to call it. And of course you have operation W, where you can use the existing data. So you use existing data, and then operation X, you add the remaining data, which is at the E over here. And then you operation Y to actually circle it, to actually mark it as the end of word. And now the word, because APE, AP you already have, so you use the existing. And then E you don't have, you add the remaining, operation X, and then operation Y, you mark it as like the end, and there you have it. And this one, we kind of like call it as being like a sample of like a existing data. And now we add the last word, is the ACE. We can kind of use the existing data, operation W, which is the A, and then add the remaining data, the C and the E, and then operation Y, mark it as like the end of the word. And now we have like all the words that's been established based off like the rulebook that's been given to us. And now we're gonna like test it with the object that's been given to us based on the rulebook. So this is on the rulebook space. So now we're gonna like interact with this space of like item G and the space of N. Let's see the interaction between N and G. So now we start with the A. Now cook, and then we go on like the all 4 different directions. Are we actually able to actually establish to be able to actually find any of the words from these guys? The first guy we actually am able to actually establish is the A, so this is cool. So operation H is that check with the first guy, like the first alphabet, and in this case it's A. It does make the operation, and now we go towards like the 4 directions. And we check whether there is like the second alphabet or not. And obviously there is. So we go the 4 directions and we actually find like a P which coincides. So one thing to take note is that we go by one word. So we go by APPP first. So APP, we go 4 directions, we find a P. We go 4 directions, we don't find a P. So therefore this word is like false. And then now you go now you try the second word. A, I check the first alphabet, 4 directions, check out for a second, and you sort of like rinse and repeat. You rinse and repeat to go for 4 directions. So you A, first word check, P you check, and now you go 4 directions, you go to a E, and therefore this guy is valid. And then you add to your results to the system. Let's say that, oh, we do have like a APE within like the G space, like the G item. So interact with N and G once again. A, and then C, 4 directions, C, 4 directions, E, and then there we have it, another word. We therefore add it to like the results box. And now this is the answer amongst like the 3 words. These 2 words can be found in the space of G when we do the interaction between the N and the G that we actually built for this N item. And if you were to sum it up, like we actually created like 2 categories of say operations where one is that we use like maybe say the brand new word, and the second one is for existing word. But fundamentally whatever we are doing, we're adding all the alphabet. It consists of us adding alphabets. It consists of us like marking the end of word. And the first item that I can actually think of, when you mark end of word, you add alphabets, you straight away will start to actually think about, oh, I'm actually using the try, and it's also known as the prefix tree. And one thing to take note is that we're using like a mechanics of between like utilizing of like the interaction between 2 spaces between the N and the G. So that's like quite a new spell in our arsenal right now. Basically comparing of like 2 spaces, like where one space is that we actually created ourselves as some form of like self-creation, and the other space is actually do belong to say created by the rulebook. And we see like the interaction between these 2 spaces, and therefore we find like the result box that we actually eventually am able to actually establish. And based on the rule book, they actually gave us like correct words, and they give us like a space of like the rule book puzzle for us to actually do some form of like interaction. So maybe when we think about this thing, we can start to think of like, oh, maybe we need to build something to actually do a comparison. That's why we built this whole prefix tree to actually do it. I mean, like, sure, you can just use the brute force way, where they actually talk a lot about it, which is that you end up having 4, and that because it's 4 directions, and it's based on like how big the box is. If given like the length is n, the length is n, the height is m, you are technically doing n times m, n times m, and obviously the length of the word, depending on how big the word is w times this whole item, which is very very brute forcey in my opinion. And this one will come under like operation J, where you do the brute force, you keep on checking every single combination possible. And how I will actually argue is operation K, where operation K is that saying that, okay, maybe say I start with like alphabet C, but the thing is this, the prefix tree, what is it gonna do is that is it gonna try to check all 25 alphabets? No, it's gonna check like the first alphabet. I only got A, there's no point for me to check C, so in the end I'm just gonna end off the loop. But when you talk about like J, it's gonna continue with C, and it's gonna go C all the 4 directions, and it's gonna like do all this extra calculation. And if you were to see K beat J out of the water, because it doesn't even need to check for C, doesn't need to check for E, and same for P. It only check for whatever's relevant, just based off like the first alphabet. It can already tell. That's how powerful K is. That's how powerful try prefix tree is. And obviously all these guys is the characters that we've introduced, and obviously you will have like always the brute force to actually fight against the main character. And how are you gonna fight? I'm just gonna use the operation K to fight operation J, where K you don't need to check all the alphabets, where J need to check for all the alphabets to just find for the C, you know. K will just say that, oh, there's no C at all in my remaining, there's only A, bye bye for C. But for J, it's going to check for C, and it's going to go through this whole entirety system. And that's how I actually fight, use K to fight against the brute force. And now this is like the spells that we've been casting so far. And obviously here's our rulebook that we managed to actually establish. And I think just that the special features of like this whole Leetcode question, it really comes down to like comparing these two spaces. And what led us to here is it was because of like the rulebook. They straight away give us like a space of like a rulebook puzzle for us to actually solve. And in order to actually solve it, yeah, we can question to actually use the brute force way. That's like one space for ourselves to actually tackle it. Or we can design like a space that is so efficient, the prefix tree, to actually do the interaction between the rulebook and the puzzle. And that's how we actually am actually to solve. And for the past Leetcode questions that we actually solve, I believe we also have always designed some form of like a efficient algorithm to do the interaction between the rulebook's puzzle and using our system to actually fight against it. That's what I actually believe. Yeah. So I'm just looking forward to actually take a look back on maybe say some of like the items that I've solved and the future questions that I'm gonna solve. That see that is it that we always constantly am introduced with this space from maybe say the Leetcode question, and we design something to actually fight against it. I believe it's a lot of to do with that. Create an algorithm to fight against the space that's we've been introduced. Yeah, and with that everything comes to an end.